Class, let's start with the second book's revision, that is optics. Yes, Krishna, how were your exams?
Yes, ma'am, they went well.
All right then. So when are you expecting to get your result for the pre-boards?
Not sure, ma'am. Actually, currently we are having holidays. Maybe they would declare the results after the holidays.
Okay, winter vacation must be going on. Okay. Fine. See, laws of reflection, angle of incidence is equal to angle of reflection. And second is that all the three rays, incident, normal, and plane, the normal lie in the same plane, incident, reflected, and the normal. Then mirrors we have seen, sign convention of the mirrors, ray diagrams. We had seen all the ray diagrams. This derivation is very important, class, relation between focus and the radius of curvature. All right, do have a look at this relation between the focus and the radius of curvature. This is an important derivation. All right, this one. And then the mirrors formulas derivation. This is also very important. Linear magnification's derivation usually does not come. Let's start with the questions then, so that we can practice and revise the complete optics unit in today's class. Yes, Khalid, your answer is correct. C class. An object is placed at a distance of 36 centimeters from a convex mirror. So this, if this is the convex mirror, here is the object, total distance is 36 centimeters. A plane mirror is placed in between so that images that are formed coincide if the plane mirror is at a distance of 24 centimeter from the object. This will be 24 centimeter. Here you just have to understand the ray diagram. Rest of the calculation is very easy. So it means this part, let's say this is the principal focus. This part is 24 centimeter. And this plane mirror is placed in between so that two virtual images are formed and they coincide. So it means this, if this is 12 centimeter, this has to be 12. If this is 24 centimeter, this part will be 12 centimeter, the leftover part, right? And the image will also be formed at 12 centimeter because for plane mirror, image and object distance is exactly at same position. So this will be 12 centimeter. So it's like object is emitting the rays. Here the virtual image is formed. Like this it is reflecting. Fine, like this it is reflecting, and same it is happening for the plane mirror. This is reflecting the light rays. This is reflecting the light rays, and this is formed when you extend it at this particular point. Here is the image. This you just have to understand. Now see, object distance is minus 36 centimeters. Image distance from pole, if you will take, this will become plus 12 centimeters. Right, so focus, if you find out using mirror formula, this is V, this is U, F will become 18 centimeter. Right, so F you have 18 centimeter, radius of curvature will be double of it, which will be 36 centimeters. Like this. So mainly here it was the ray diagram that you have to identify. Note it down, some more questions, let's see. Again, Khalid's answer is correct. Others, C. A thin rod of length f/3 is placed along the optical axis. Optical axis means what? Principal axis of a concave mirror. So let's say here is your concave mirror. If somebody is near their answer, so you can keep trying. All right. And then a thin rod of length. So length of the rod is placed along the optical axis. See, this is like, let's say, this is the rod that is kept. The length is f/3 of the rod. All right. Let's say this is center of curvature. This is a point. Good, Salman. Yes. Yes, Khalid. You have to draw ray diagrams in every question. In some of the questions, ray diagrams will be given to you. In some questions, you have to draw it. Also, in the questions in which ray diagrams are given, they'll be incomplete because the rest of the completion part will be required from you when you solve it. So yes, please draw it. A good thing that you pointed it out, Khalid. I wanted to announce this also. In your answers, do draw the ray diagrams wherever possible. Even in your board exams in any subject, wherever diagrams are there, no? Be it ray diagrams in your physics, be it normal diagrams in your bio and other subjects, you have to draw wherever diagram can be drawn. All right, so ray diagrams are necessary because in the ray diagrams, most thing like here I have marked it as AC. Now without drawing this ray diagram, if I write it in my answer sheet as directly AC 8-C like this, then nobody is going to understand what is A, what is C. So for better clearance also, we have to draw it. All right, so of a concave mirror of focal length F. So focal length is F, this entire will be 2F. Right, such that its image, which is real and elongated, just touches the rod. So it means real and elongated. Let's say this is the image and this is touching. So this will also be lying at the center of curvature. Right, see, image of the rod placed along the optical axis will touch the rod only when one end is placed at the center of curvature. Right, then only it will be formed at exactly at the same position. This is what we have seen. That's why I've drawn it on the center of curvature. This is not mentioned in the question that you have to draw it on the center of curvature. Why have I drawn it? Because it is saying it just touches it. And see, this is how your theory gets applied into your numericals. You have to do the application part by yourself. Understood? Since it is just touching it, it means center of curvature, the object is kept at the center of curvature, then only image is also formed at the center of curvature. And elongated, that is also mentioned. Now we have to find out the magnification. Let's say this is A-C, and AC we have, this is the image. So for the end A of the rod, this end, let's say this is point P, this end A of the rod, we have to find PA, no? So PA will be how much? See, this entire is 2F. So F/3, if you subtract, that will be 5F/3, right? 5F hoga na? Yes, 5F/3. So this part will be object distance will be F/3. If you just look at this edge as the reference, object distance is F/3. Focus is F. Focus is F. Object distance becomes F/3. Let's see where the image distance is formed. See, if you apply 1/V will be 1/F minus 1/U. 1/F minus reciprocal. So 5 gets multiplied to 2/5F. So V will be 5F/2. Image distance will be 5F/2. Right. So length of image will be, see, if somewhere 5F/2 image has been formed. So if you want to find out the length of image, then you have to subtract 2F. This now you have understood, you have got this point. PA dash you have got, this entire image distance you have got, that is F5F/2. 5F/2 is this part. Now you have to find the length of image. Length of image was asked. No, what will be the magnification? For magnification, you have to have the length of image. So what will be this? This entire is 5f by 2. This part is 2f. So subtract 2f from here. You will get this remaining part. This will be 5f by 2. This value of a dash c will be simply if you subtract pa dash minus pc, that is 5f by 2 minus 2f. That makes it 415. So 5f by minus 1, 5f, f by 2. Now see the magnification. Magnification is height of image by length, height of image by height of object. Right here, we'll try. This is actually transverse magnification. This is not linear magnification. Two types of magnification we had seen. One was transverse magnification, which you use. This is longitudinal magnification. Here we take length of image by length of object. So length of image is CA dash, original image is CA. So CA dash is F by 2, CA is F by 3. FF gets cancelled. This becomes 3 by 2 or 1.5. This is the magnification. Clear? Is it clear to all of you?
Ma'am, we can also use minus v by u, right? We can also use minus v by u, right, for magnification.
Yes, minus v by u also. Minus v by u also. That also you can use. This was just, I was telling you about longitudinal magnification, where length is used, not the height. You can use v by u. Both are correct. You will get the same answer by both of it. All right, note it down, class. Question I think you all have written. Note it down. Here mu means refractive index. Mu for glass is 1.5, A material is 1.4 and B material is 1.3. See, class, here you will use the formula. We have seen the formula for the depth of it. Ng fraction we had. Let me just show you. Depth of glass slabs. No, we had seen depth of glass slabs here. Shift. This was a lateral shift. Just a second. So if you have multiple of it connected, apparent shift we did, no? In the apparent shift when we did, it's not opening here. Apparent depth. So d1 by mu, which you had seen. Just a second. This formula, shift. D real 1 minus 1 by n. So this is for a single slab. If you have multiple, like here, A and B, two materials. So how do you use this? Total shift is given by C. This is a formula, remember it. This will be used in your exam solving also. See, depth will be first thickness, then 1 minus first refractive index. Then you add it with the second thickness, 1 minus 1 by mu2. Then plus T3 plus T3 1 minus 1 by mu3, like this you will use. See here, T1, first thickness in the question, it is given as 4 centimeter. Second thickness will be 6 centimeter. Third thickness will be 8 centimeters as per the question. And see, mu1 is also given glass 1.5. Mu2 is also given 1.4, no? 1.4. And mu3 is given, yes, 1.3. So if you put it in the formula, this will be 4, 1 minus 1 by 1.5 plus 6, 1 minus 1.4 plus 8, 1 minus 1.3. So see what's the answer coming. This should be 1.33, or just calculate this part by yourself. Let me know what answer you're getting. Yes, it will be 5, around 4.89 precisely. Correct, Salman. The refractive index of water is 4/3 given. Obtain the value of the semi-vertical angle of the cone within which the entire outside view would be confined for a fish underwater. See if, let's say, this is the cone. If the fish is over here, the fish will look here, and same way it will go for both the side. Fish can see the outside view of the cone. This part of the cone the fish can see. Now look here. If this entire angle, let's say this is some theta, so half of it will be theta by 2. And when is this case possible? This is only one condition, that is critical angle. So it means critical angle here is theta by 2. This entire is theta, so this half of it will be theta by 2 only, just this part if you talk about. This is just theta by 2, right? So see, the refractive index will be 1 by sine IC, and refractive index is given 4/3. So 4/3 is equal to 1 by sine IC. So sine IC will become 3/4, will be 0.75. So IC will be, how much will be critical angle? Sine inverse. We have to find the angle only, no? Semi-vertical angle. Yes, sine inverse 0.75. Just the critical angle, you had to find it out. Note it down. Some questions on lens, let us see now. See, radii of the curvature of a double convex lens of glasses. Glass is 1.5, the refractive index. They are in the ratio 1:2. So this refractive index that is given is 1.5. Then it says that this lens renders the rays pulled coming from an illuminated filament at a distance of 6 centimeters. Means focal length is 6 centimeters. You have to calculate the radii of its curvature. See, if R1, first radii of curvature is R1. It's in the ratio 1:2. So R2 will be, directly we'll write it as -2R. Double because the ratio is 1:2, and 1 it will be negative because it is double convex lens. This double convex lens. So 1 will be plus R, this will be minus R, and this will be plus R. This will be negative minus R. So if you keep it in the lens maker formula, 1 by F is equal to mu minus 1, 1 by R1 minus 1 by R2. See, all these are previous year's question class. So do not ignore these when you are revising after the class notes. Do look at these questions also. So 1 by 6 will be 1.5 minus 1. This will be 1 by R minus 1 by minus R2, no? So plus 1 by 2R. 1 by 6 is equal to 0.5. This will be 3 by 2R, right? So radius of curvature will be 0.5 into 3 into 6 divided by this 2. So this 3, 9, 9.5, 4.5, 4.5 centimeter. So R1 will be 4.5 centimeter, R2 will be 9 centimeter. This was an easy question, class. Nobody sent me the answer. Atif, Khalid, Krishna, Memuna, Salman. Note down the solution. Let's see some more questions from this lesson, then we'll move on to wave optics also.
Ma'am, can you explain why we took F as 6 centimeters?
See, F as 6 centimeter we have taken because see, this is saying what? This lens renders the rays pulled coming from an illuminated filament at a distance of 6 centimeter. It means lens is taking out the double lens is there, right? This lens is there. Some source is there which is kept at such a distance. This means what? This line basically, this line that I have written, this lens renders the rays parallel coming. So if the rays, here one more word should be mentioned, that was parallel, then only it will become clear. You can add it. Parallel coming from an illuminated filament. So this will make it more clear. Parallel it is, so it means object is kept at such a point from which the rays will ultimately become parallel, and that point will only be the focus of it. So that's why just change this is parallel. Then only with the word parallel, then I think it will become clearer for you. Because if it is, the rays are becoming parallel, it means object must be kept at focus, then only the rays are becoming parallel. That's why I've taken focus as 6 centimeters. And R1 came out to be 4.5. This is 4.5. 4.5. So double of it will be 9 centimeters. See, a prism of refracting angle 60 degree gives angle of minimum deviation 53, 51, 52 for blue, red, and yellow light. Dispersive power. See, dispersive power, the formula for dispersive power is angle of deviation for violet or blue. Here it will be better if I write blue, minus angle of deviation for red divided by angle of deviation for yellow. So this is 53 minus 51 by 52. So 2 by 52. So this will be 0.038. This is it. Why didn't you all try this? Calculations is very easy for this part. The calculation is fine for the questions from dispersive power, deviation, prism questions. The calculation part won't be difficult. Even from prism part, calculation part will not be difficult. It's just that you have to analyze and understand the question. Note it down. Then let's see some question from wave optics. Yes, Atif, Krishna, both are correct. Answer will be 5 millimeters. See how. Amplitude resultant of the amplitude that we write. This will be under root A1 square plus A2 square plus 2 A1 A2 into cos phi. So one is 3 millimeters, second is 4 millimeters. The resultant angle is pi by 2. So resultant amplitude, this will be 3 square plus 4 square. See, this is pi by 2. So this entire term will be 0. So this will be 5 millimeter because this is Pythagorean triplet also. This way you will get your answer. Quickly note it down. Those who have not written, we'll see some more questions. Yes, class answers. See this question. Lambda 1 is given. So if lambda 1 is given, 6,000 angstrom, lambda 1 is 6,000 angstrom. And beta 1 is given to you as 0.8 millimeters. Lambda 2 is here given you 7,500 angstrom. This part, right? 6,000 here, this. And you have to find out beta 2. So beta 2 will be, see, width in the first case, if you calculate, fringe width, this will be lambda 1 capital D by small d. If you calculated it in the second case, it says that light source is replaced by another and slits is doubled. So that will become 2D. See, for the second case, beta 2, this will be d lambda 2, but here it will be twice the slit. Now take the ratios. If you take the ratios of beta 2 by beta 1, you will get 1 by 2 lambda 2 by lambda 1 into beta 1, because d, capital D and small d both will get cancelled. Now beta from here, not beta 1 will not come here then. If I have written it over there. Now see, beta 2 will be this, beta 2 will be half. Lambda 2 was 7,500 angstrom. Do not convert it, everything will be cancelled. This is 6,000 angstrom and beta 1 is 0.8 millimeters. 0, 0, 0, 0 cancels. Here we have 2. Here we have 0.4 millimeter. Do not convert millimeter also, because we'll keep our answer in millimeter. So your answer will be 0.5 millimeter. This is how you'll calculate this. Note down the solution. And class, keep trying it yourself. I give you 5 minutes time so that you can try it by yourself. And any doubts if you have, that can be clarified. This part I'll tell you. See, this is actually a question from your NCERT. That's why I'm discussing. This is not a question from previous year, though it has come in your previous years. This is actually Fresnel distance, the approximate distance now for this ray optics, when ray optics becomes a good approximation. But though you have Fraunhofer distance in your syllabus, by chance Fresnel distance, if anything that has to be come from Fresnel distance, it will be this part only. See, the distance up to which a beam of light can travel without significant broadening. This is known as Fresnel distance, and its value is given by a square by lambda. So aperture's width is 3 into 10 to the power minus 3 whole square. Revise this question at the last. This is not very important. It's just that it has slight chance it can come. 500 into 10 to the power 9 minus 9 nanometer. No, so 9, 5 by 9, 19. Then that becomes 18 meter. This will be 18 meter. This will be the answer for it. Yes, class, answer this part, first and second part. Energy, what will happen to energy frequency if the light enters from air into glass? This question came last in 2017 and 2013. Very easy question. All of you should answer. Answer me in the chat box. Yes, answer for this. Atif, Khalid, Krishna, Memuna, Salman. Energy. According to you, what will happen to the energy? Energy. Yes, Krishna. Second part is correct, Krishna. First part. Khalid is right. Khalid, any reason? Any reason for this, Khalid? Second part is correct, Krishna. First part. Energy is not dependent. See, energy of the wave decreases because part of the light wave is reflected back into the air. That's why it decreases. R is 5. Okay, this was the previous one. No. Frequency, yes, Krishna was right. Frequency, it remains constant. See, frequency of the wave remains unchanged. It does not depend. Yes, Khalid. Frequency, no change. Both of you are right. Second part will be frequency remains constant. But understand for the first part, energy will decrease. That was right, Khalid. See, energy decreases. But the reason is that part of the light wave is reflected back into air. Part of light wave is reflected back into air. That's why. And yes, for the second part, frequency remains unchanged. This is independent. Had it been velocity or wavelength, then these will change, but frequency remains unchanged because yes, Salman, energy decrease because a part of light wave is reflected back into your frequency. That's what I've written. All right, then note it down. Text me done once you have written. Then I'll stop it. Then we'll be left with the revision of modern physics and semiconductor.